Hello, welcome to Amay Kadam's channel. In this lecture, we will see one more numerical on composite low pass filter using image parameter method, and the specifications are given. R050, FC 50 MHz and F infinity 52 MHz. So this is a low pass filter. So we'll recall the formulas. The composite low pass filter consists of 4 sections. You have matching section at the input side, again one more matching section at the output side. You have constant K section and M derived section. So first we'll calculate the composite constant KT section per network elements. So these are the formulae. So omega C is 2 pi FC, which is 2 into pi into 50 into 10 to the power 6, while omega infinity is 2 pi F infinity, which is 2 into pi into 52 into 10 to the power 6, and R0 they have mentioned is 50 ohm. So we'll substitute. So this will become 2 into 50 divided by omega C, and it turns out to be 3.18 into 10 to the power minus 7 Henry, while the capacitor value turns out to be 127 picofarad. But the component value is L by 2, so this value turns out to be 159 nanohenry, because this one can write as 318 nanohenry. So 318 divided by 2, it will turns out to be 159 nanohenry. The aim of the constant K section is to provide attenuation in the stop band. Now we have M derived T section. So since this is a low pass filter, you will have ML by 2, ML by 2, you will have MC and another component over here, inductor, that is 1 minus M square divided by 4M into L. And the M can be calculated as 1 minus FC by F infinity the whole square. So we will substitute this thing, and M turns out to be, yes, 0.275. So we will substitute these values and L over here, L and C from this one, and we can calculate these values. So this turns out to be 43.7 nanohenry. This MC turns out to be 34.9 picofarad. You can check the calculation, and this turns out to be 267 nanohenry. So after constant K M derived at the input and output side, we require bisected pi matching section, and for designing this one it is fixed that M has to be 0.6. So we'll take M is equal to 0.6, L is equal to 318 nanohenry divided by 2, so it turns out to be 95.4 nanohenry. M as 0.6, capacitor 127 pico divided by 2, so it turns out to be 38.1 picofarad. Similarly, we can calculate this one, 170, it turns out to be 170 nanohenry. In the last lecture, I told you the technique to remember the formula. So you have 1 minus M square by 4M into L over here. This 4 you have to split as 2 over here and another 2 over here for designing bisected pi matching section. But here the M is defined by omega C and omega infinity, while in bisected pi matching section M is fixed, that is 0.6. So we'll cascade all these blocks and you will have a network somewhat like this. So we'll have a matching section over here, then you will have constant K section, then you will have M derived section, and then you will have a bisected pi matching section. So here one can have impedance R0 is equal to 50 ohm. Here R0 is equal to 50 ohm, and one can write down the component values. So this one will be 95.4 nanohenry. This is 170 nanohenry. 38.1 picofarad. Here you have constant K, so 159. And for by M derived section, you have ml by 2, that is 43.7 nanohenry. This is nothing but 267 nanohenry. So that completes the design of composite low pass filter. In some of the textbook, while mentioning the answer, they add these two inductances and place only one inductor of its equivalent. So even they can add these two inductor and place one inductor over here, so don't get confused. One can even write this as an answer. So we'll proceed for the next part, that is high pass filter design using image parameter method.